Hello everyone. I have to be gone today with the soccer team, so as I've done in the past, I had to record the lesson. We are going to be working on section 1.6 today, which I'll discuss in a moment. But to start, you should have your homework out to the last day of 1.5 that we completed yesterday. The answers to that are right here, so I'm going to read them off. If we need to pause the video to ensure that everyone has their homework out, go ahead and do so. Otherwise, I'm going to start. So the last section of 1.5 concerned itself with interpreting the discriminant and then solving any quadratic by your method of choice, taking square roots, factoring, using the quadratic formula, or completing the square. So first three questions dealt with the discriminant. Question 75, the discriminant is positive, and you can take the square roots of positive numbers, so there's going to be two real answers. It was 36 was the discriminant's value. 79, the discriminant's value was 0. You can also take the square root of 0, but there's no such thing as plus or minus 0, so there's only going to be one real answer. Question 80, the discriminant was negative, which means if you were trying to do the quadratic formula, you'd be needing to take the square root of a negative number. In prior math classes, you would have said there are no real solutions, but now we learned about how complex numbers can be used, so we would say that they're two complex or imaginary solutions. 85, the two answers are 1/5 and 2. 89, the two answers are 1 plus the square root of 2 and 1 minus the square root of 2. 97, the two answers are plus or minus 2. 103, it's 0 and 3.5. 141, it's approximately 4.5. And 156 and 158 are left for you to explain. Here are your answers. If you need to ask a question about any of them, circle them. Have them ready when I come back, and I'll check this for credit when I return. We're now going to move on to section 1.6. So have your note packet out. Again, if we need to pause the video, go ahead and do so. Otherwise, I'm going to assume that we're good to go, and I'm going to move forward. So in this whole chapter, chapter 1 was all types of a review, really, of solving equations. These are all things that I know are covered in Algebra 1 and Algebra 2. But this is kind of an overview of the skills related to solving a variety of equations. So far, we have solved really three types. We've solved linear equations. We've solved some rational equations, and then we've solved some quadratic equations. Today we kind of have a smorgasbord, all the ones that are left, and we'll just do some of the basic examples for those. So we're going to solve larger polynomials by factoring, kind of an extension of what we did in quadratics. In equations type 2, we're going to be solving radical or square root equations. We'll be undoing square roots by squaring. In 3, we'll be doing equations that have rational exponents by using the reciprocal exponent. And then in 4, we're going to be solving absolute value equations, equations that were solved in Algebra 1 and Algebra 2. So we're just going to be working through them one at a time. The very first one was solving polynomials by factoring. There are 3 different types of factoring you can do depending on how they set up. So this first one is going to be an example of greatest common factor factoring. Usually you know this because there's not that many terms. If I'm going to be doing greatest common factor factoring, I'm going to be doing it by getting one side equal to 0. And actually that's going to be a theme throughout all of the factoring. You need one side equal to 0. So I'm going to subtract the 20x. Now when there's only 2 terms, that's almost always a dead giveaway that you have a greatest common factor factoring. So I ask myself, what's the biggest number I can divide out of 4 and negative 20? And of course that is 4. Then I do the same for the variable part. How many x's can I divide out of both? This one has 3, this one only has 1, so I can only divide 1 out. In parentheses, I write what is left behind. This was originally a 4, but I divided a 4 out, so there's a 1. This was x cubed. If I divide 1 x out, I have 2 x's left, so that's x squared. This was a negative 20. I divided out of 4, so a minus 5 is left behind. This only had 1 x. I divided it out, so I've factored it. Now this equals 0. Now I go solving. What can I multiply 4 by to make 0? Well, that's obviously going to be 0. This one I need to solve. I need x squared minus 5 equal to 0. So I get x squared equals 5. And then when I take a square root, I'm going to get x is equal to plus or minus. When you are taking a square root, you need to add the plus or minus. So, example, square root of 16 could be 4 or negative 4. The square root of 5 is not a particularly nice number. If you type it in your calculator, we can estimate it to a decimal, and we would have just a few decimal places out. It looks like 2.2 236 if you were to estimate it with the decimal instead of writing the square root of 5. So that's an example of greatest common factor factoring, typically when there's only two terms. Factor by grouping. This one will tell you, this is a tough skill to know, to recognize. It's used when you have longer expressions. You need at least 4. And so I would tell you that you're going to be using grouping if I were to ask you to do it on an assessment. But you still need one side equal to 0, so we do 2x cubed plus 3x squared. Then I subtract minus 8x minus 12 equals 0. We still need one side equal to 0. The idea by grouping is really it's a longer version of what we just did in greatest common factor factoring. I essentially do greatest common factoring on this first pair, and then I do greatest common factoring on this second pair of numbers. So let's try it. So, first pair, I look at this and do a greatest common factor factoring. So what's the biggest number I can divide out of 2 and 3? Well, 1. So I really can't divide anything out. What about x cubed and x squared? Well, I could divide out an x. So I divide out an x. Actually, I could do 2 of them because this second one has 2. Then in parentheses, I write everything that's left behind. There'd be a 2, an x, and a plus 3. Then I do the exact same thing over here. I ask myself, what's the biggest number I can divide out of -8 and -12? Well, that's going to be actually a -4. They don't both have x's, so I can't divide that out. So in parentheses, I write what's left behind. A -8 dividing out a -4 is going to be a 2. This has an x. -12 dividing out a -4 will leave a +3 behind, equals 0. Now if I go looking, hey, this was the blue statement, this is the green statement. If I look at them, they both have an x plus 3. So now it's kind of like a greatest common factor with these two. I can divide out a 2x plus 3 from both of them. What's left behind is an x squared minus a 4. Now I have them multiplying equals 0, so I use what's called the zero product property. I know that either this first parenthesis is 0, so if 2x plus 3 were equal to 0 and I solved, I would subtract 3 and divide by 2, and that would make -1.5, -3/2. Over here, this could be 0. I could have x squared minus 4 equaling 0. If I solve, I get x squared equals 4. If I take a square root of both sides, I then get plus or minus 2. So there you go. You'll notice something though. This was a power of 3, and I had 3 answers. This over here was a power of 3, and I had at least 3 answers, and also at most. That's a property that we'll see and look at more going down the line. I just wanted to point it out now. Okay, last one. This is a substitution. The way that we look at this is, hey, this kind of would be easier to solve, if this was something like, if this was u squared minus 5u plus 6 equals 0, I could probably solve this by factoring. I could find two numbers that multiply to make 6 and add up to be -5. So let's do that. Let's make that substitution step. Let's let u, as I can see, I have u equaling x squared here. Let's do that, and then if I solve this blue one, I can use the fact that I know what u is to figure out what x is. So we're going to make a substitution here. We're going to let u equal x squared, and then we're going to solve this blue one right here. So what two numbers multiply to be 6 and add up to be -5? Well, that's going to be -2 and -3. Then I can solve both of these. This would be if u equaled 2 and if u equaled 3. But the original equation didn't ask about u, it asked about x. And I can use the fact that I know what u is. U is equal to x squared. So if u equals 2, that actually means that x squared equals 2. If u equals 3, that actually means that x squared equals 3. And then I can solve by just taking a square root of both sides. So take a square root of this side. I then get plus or minus the square root of 2. It's approximately 1.41. Same thing will happen here. Take a square root of both sides. And I'm going to get plus or minus square root of 3. And those are all of the ways that you can solve polynomials. Greatest common factor factoring, grouping, substitution. All of the questions in the homework will be of this form. And so if you show your steps in your homework, then you should have no trouble with the quiz question because you would have an example for every single type of skill that could be asked for solving an equation by solving a polynomial equation. So that is the first one. So we've got polynomial by factoring. The second type of equation are radicals. The steps for solving a radical equation is a root equation. It's the math term for a root, is to first isolate the radical term, get the radical term all by itself. So in this one, that would be one step. That would be subtract this 3 right here. So when I subtract this 3 from both sides, I'm then going to be left with square root of x plus 3 equals x minus 3. That's step 1. Isolate the radical term. Now I need to undo the square root. How do I do that? I raise both sides to the power that eliminates the radical. And this one would be to square both sides. So I need to square both sides. When I square a square root, these cancel each other out. So this square and this square root cancel each other. I'm left with x plus 3. Over here then, I need to multiply it out, FOIL it out. Double distribution, however you want to think about it. If you want to use a table, do it. X times x will be x squared. Then x times minus 3 is minus 3x. Then the negative 3 distributes. I get minus 3x. Then the negative 3 multiplies the negative 3, and I get plus 9. I'm going to clean up the right-hand side. I get x plus 3 equals x squared. Is that minus 6x plus 9? Now I'm here. I've done step 2. Now, step 3 is just solve the resulting equation. Okay? Well, this is a quadratic, and almost every quadratic we solve, we need one side equal to 0. So I'm going to subtract x and subtract 3 from both sides. When I do that, I'll end up with negative 6x. If I subtract another x, I'll be at minus 6. If I subtract a 3, I'll then be at plus 6. So now I can solve it by factoring. What two numbers multiply to make 6 and add up to be negative 7? That's going to be, what, minus 1 and minus 6. The order in which you write them is not important. And then that means that my two possible solutions are x equals 1 and x equals 6. But then you need to do the last step, and that is you need to check all answers. Some might be what we call extraneous, extra, meaning unnecessary and false. So take a look at this one. So back here, there was a pattern going on. When the highest power was a 3, we had 3 answers. When the highest power was a 3, we had 3 answers. Highest power was a 4, we had 4 answers, because plus or minus this one, plus or minus this one. Over here, the highest power really is a 1, because this is a square root, which is a power of 1/2. So that means if the highest power is a 1, we're probably just going to have one answer here, but I have 2, which means one of them must be false. So if I check both of them by plugging them in, I'll see which one's the false one. So let's check x equals 1 to start. If I put 1 in there, I get square root of 1 plus 3 equals 1. 1 plus 3 is 4. The square root of 4 is 2. 2 plus 3 does not equal 1. So it looks like x equals 1 is the false one, but I should check to make sure that 6 actually works. Square root of 6 plus 3 plus 3, does that equal 6? The square root of 9 is 3, and I get 3 plus 3 equals 6. That's true, which means that x equals 6 must actually be the true solution. So this right here is what we'd say is extraneous, extra, and not true. So when you have a radical one, there are times where they might have 2 answers, but really only one of them is the true one. So make sure that you check all answers. I'm going to give you a chance to try. So this is what I'm going to do. I'm going to say 1/2 of the room. Let's say the first 2 rows closest to the window are going to be, or I guess first 2 columns from the perspective of our guest teacher, are going to try this first one right here. This is an example of substitution that we did earlier. The other 3 columns, the ones closer to the door, you have this one. You have to solve the radical equation. So pause the video now, come back after you've had a chance to try, and I'll show you what the answers are and see how you did. Okay, here's your solutions. This first one, there should be 4. 2 of them are real, 2 of them require imaginary numbers because you'd be taking the square root of a -1. So you get plus or minus 3, plus or minus I, plus or minus the square root of -1. Over here, the only true solution you had was 5. There was an extraneous solution outside of 5 that was not true. So there's your 2 answers. So far, we've done all different ways of solving polynomials. By factoring, we've done radicals. We have 2 left. The first one's rational exponents. So the steps for solving a rational exponent are to first isolate the term with the rational exponent. It's exactly what we did with radicals. Rational exponents just means fractional. You might recognize the word ratio in there. Step 2 is to raise both sides to the reciprocal power, and note that odd powers only have one root. If you see that the numerator power to start is even, then your final answer is going to have plus or minus. Step 3 is to check all answers. So here we go. First step is to isolate the term with the rational exponent. So essentially get this item all by itself. How are we going to do that? Well, add the 25 over. So then I'll have 5x to the 3 halves equals 25. I still haven't isolated the term with the rational exponent. I need to divide both sides by 5. So divide by 5, divide by 5. I then have x to the 3 halves equals 25 divided by 5 is 5. My goal, though, is to figure out what x is by itself, not x to the 3 halves. I want x to the first power. So I want x to the first power. How am I going to make this be a first power? Well, how do I get rid of 3 halves? I multiply by 2/3. If I raise this side to the 2/3, I also need to raise this side to the 2/3. And then when I do that, I will have x to the first. So I get x to the first equals, and then you can just grab your calculator and type in 5, this is your exponent property, put parentheses since it's a fraction, 2/3, end up with 2.92. It's essentially going to be the cube root of 25. So 2.92. So x equals 2.92. We only have one solution because my numerator power to start, which was a 3, is odd. So you only have one solution. You can check your answer by putting it back in. If I put 2.92 in here, let's check it. So 5, parenthesis 2.92 to the original equation, to the power of 3 halves, so to the power of 3 divided by 2. And then if I subtract 25 from that, it should be 0. And it would be, we just rounded this answer, 2.92. If we went out more decimal places, this would be exactly 0. So my answer is correct. Last one, absolute value. Before getting into our last type of equation, let's recall what the absolute value sign even means. For example, why are all of these true? Why is the absolute value 5, 5? Why is the absolute value of negative 5, 5? Why is the absolute value of 0, 0? It's because the absolute value is the distance the item is away from 0, and distance can only be positive. So for example, if we have the equation, which we'll be solving, equation like absolute value of x plus 3 equals 8, this translates to x plus 3's distance away from 0 is 8, which means x plus 3 is either located at negative 8 or positive 8. That's the only way that x plus 3 could be 8 away from 0, would be if x plus 3 was at negative 8 or x plus 3 was at positive 8. And that's how we're going to solve these equations, is essentially by translating. So step 1, like it's kind of been for the other ones, is to isolate the item that you're trying to solve for. In this case, it's an absolute value. So get the absolute value statement all by itself. We're going to do that by first adding 20 and then dividing by 4. So I'll add the 20 to the other side first. Then I divide both sides by 4. I'll be left with then the absolute value of 1 minus 2x equals 5. That's step 1. Step 2 is to translate to the two locations the expression could be located. You're going to get two answers for absolute values because absolute value has distance away from 0, and there's always two numbers that are equal distance away from 0. So this right now is saying that 1 minus 2x, that whole thing's distance, this is an apostrophe s as in possessive, distance from 0 is 5. That means that 1 minus 2x could be in one of two places. Either 1 minus 2x is located at negative 5, or 1 minus 2x is located at positive 5. And then I solve. How do I solve this? I subtract 1. I then get negative 2x equals negative 6. Divide by a negative 2, and I get 3. Same thing, subtract 1, I then get negative 2x equals 4. Divide by a negative 2, and I get negative 2. And if you substitute and check by putting both answers into the original statement, you'll see that they both check out. So get the absolute value by itself, then translate into the two locations where that item could be located. Going to give you a final chance to try one of those by solving this one. Make sure to think about if your answer is making sense as you're solving it along each step. So pause the video now, unpause it after you had a minute to try. Make sure as you're doing each step that each step makes logical sense, because this one has a unique solution. So pause the video now, come back after you've had a chance to try. Okay, I told you to, be careful with solving each step. You're trying to get this item by itself, you'd subtract 28 and then divide by 7. This one turns out to be a no solution. Why does that happen? Well, when you subtract 28 and then divide by 7, you get that 3x minus 2 is equal to negative 4. You're telling me that 3x minus 2's distance from 0 is equal to a negative, or you're telling me that an absolute value statement is going to output a negative number. That's never going to be true. So if you ever have an absolute value equals a negative number, when the absolute value is all by itself, then you automatically know it's no solution. You can't have a negative distance from 0. Your absolute value is never going to output a negative number. So there we go. Kind of a larger section, a hodgepodge of skills, but all review. I know you've seen these things before. Maybe hopefully some of the pieces are coming together. So that is it for the section. The homework answers as you work are right here. If you want to pause a video after it's ended and just leave these answers up, you can check your work as you go. Have any questions ready for me when I return, and have a good day.